In this video, we're going to look at several key building blocks of a Python program. Variables are used to store a value so that we can use it later on. So you can see here I'm taking the value 77 and storing it in the variable temp for temperature. And I'm doing that in the Python shell. And then when I enter that command, you'll notice that you don't see any value produced. And that's because we're not producing a value here, rather we're just storing 77 in a variable. But then I can use that variable to compute other things. So I could convert the temperature from Fahrenheit to Celsius, and if I enter this expression, you'll see that we end up with 25.0. So variables are one key building block. Another key building block is an expression. And in computer science, an expression is anything that produces a value. We evaluate them to obtain their value. And we're used to thinking of expressions in math as always having operators, but they don't need to. Individual literals, single hard-coded values that we put in our program, like a single floating point number or a single string, on their own are expressions because they give us a value. Single variables on their own are also expressions. They give us whatever value is inside them. And then of course you can have combinations that include operators. Now if you have an expression with a variable, the very first thing that happens is the variable gets replaced with its current value. And then you go on and do the rest of the math to get the final value. But variables always get replaced first. Another key building block is a statement, which is a command that carries out some action. And when we write a program, we're really just putting a sequence of statements together, and they're going to get executed sequentially. And we'll talk more about this particular program, which has 6 statements, later on. But first, I want to talk more about a particular kind of statement, which is the statement that we use to give a value to a variable. And these are known as assignment statements. In general, we're going to have the equal sign, which is actually known as the assignment operator. And then on the right-hand side of the equal sign is some expression that will give us a value. And then we're going to store that value in whatever variable is on the left-hand side. And it's really important to get the order of this right. So we always start by evaluating the expression on the right-hand side, and then whatever value is produced gets stored in the variable on the left-hand side. So for example here, 10 is the expression. It evaluates to itself, and then that value gets stored in the variable quarters. In this assignment statement, we first evaluate the variable, we then do the multiplication, and then that final value is stored in the variable. It can help to picture variables as boxes in the computer's memory. So here you can see that we have one box for the variable num1, and I've assigned it the value 100. And we have another box for the variable num2, and I've assigned it the value 120. It's perfectly okay to change the value of a variable over time. So here I'm reassigning num1 the value 50, and so now the picture in memory is going to look like this. Then I'm changing it again. So here I'm saying, let's take the current value of num2, which is 120, multiply it by 2, and then that final value, 240, is getting stored into num1. So I've changed num1 again. Now let's say we change num2 to be 60. Here again we're evaluating the right-hand side, but the 60 just evaluates to itself, and we store that in num2. And the question is, what is the value of num1 at this point? And it turns out that it has not changed. It is still 240. So even though we set up here that num1 was assigned the value of num2 times 2, that did not create a permanent relationship between those two variables. Changing num2 does not change num1. So that's a really important point here. Assignment statements do not create permanent relationships between variables, and you can only change the value of a given variable by assigning it a new value. So the only way we could change the value of num1 is to assign something to num1. Alright, now the other thing you can do, which may seem odd at first, is the same variable can appear on both sides of the assignment operator. So here I have a variable called sum, which I've assigned 13, another variable called val that I've assigned 30, and then I'm going to do this assignment statement here. And you can see sum appears on both sides. So what does that mean? Well, it means, like any other assignment statement, that we're going to start by evaluating the right-hand side. So we're going to take the current value of sum, add it to the current value of val. That gives us 43. And then that result is going to get stored back into sum. So we've based the new value of sum on the old value of sum. Here's another example. We take the current value of val, multiply it by 2, and then that result is stored back into val. So val is now 60. And here again, changing val does not change sum. Now, once you have a collection of statements, you typically want to be able to keep them around and use them again. And so we're going to put them in a text file, and we're going to store them in a file that has a name whose extension is .py. So in this case, I've taken this collection of statements and I'm storing them in a file called coins.py. And I've already got that here on my machine. And you can see here I'm using a text editor that comes with Python, and it gives me some nice color coding. And I've actually added in a blank line here. That's perfectly okay. I've also put in a comment so that I can explain what the program does. Comments begin with this hashtag symbol, and they are not executed. They're ignored by Python. They're just a good way to document what you're doing. And you can see comments show up as red in Python. Now we can run this program by coming up here and clicking Run and then Run Module. Module is another name for a program. And then down here in the shell, you'll see the result of the program, which is to tell me what this collection of coins up here, which I'm using 4 different variables for, what its value is. So you can see here I'm using an assignment statement to figure out the value and assign it to a variable called cents. And then I'm using a new type of statement called a print statement to print the result. Print statements begin with the keyword print, and then in parentheses we have one or more expressions separated by commas. Those expressions are evaluated first, and then the resulting values are displayed on the same line, separated by spaces. For a blank line, we can just omit the expressions, but you still need the parentheses. Here's one example. We have 3 expressions being printed. Again, they are evaluated first. So the string literal here evaluates to itself. These mathematical expressions are evaluated. And then those final values are printed, separated by spaces. So the blue stuff here is what actually gets printed. Notice that for strings, the quotes that surround the string literals don't get printed. Here's the print statement from our program. So let's assume again that cents is assigned 89. We're then printing a string literal followed by the variable cents followed by the string cents. And notice the distinction there. Here we have the variable cents because there are no quotes. Here we do have quotes. So this is not the variable, it's a string. And so when we evaluate those, the variable evaluates to its value, but the string evaluates to itself. And so the final output is what you see here in blue. Now, one final thing I want to briefly talk about is the type function, which lets you figure out the type of an expression. If you give it a string literal, it'll give you this type, str, which is what we use for strings. If you give it an expression like 5/2, remember the single slash always gives us a float, so the type of that is float. Now variables don't have a fixed type in Python, so if I assign 25.0 to temp, and then I say type temp, I'm going to get float because the current value of temp is a float. But if I then reassign it in int, and I do type temp again, I'm going to get int because now temp represents an integer.